Now we shall discuss some important questions and their answers. So here is question number 1. Acid ion, that is N3 minus, is linear, but hydroazoic acid N3H is a bent molecule. Why? The answer is, this can be explained by drawing their structures and noting the hybridization of central atom. Thus, in N3 minus ion, the central nitrogen is sp hybridized, hence it is linear, as shown in the adjoining figure. But in N3H, one of the terminal nitrogen is attached to hydrogen, and that nitrogen is sp2 hybridized, as shown in the figure. We see that the bond angle is 112 degree. There is a decrease in the bond angle, and it is due to the presence of lone pair on the nitrogen atom. Therefore, N3H is a bent molecule at the terminal nitrogen atom. Question number 2. Compounds SiH3NCO and CH3NCO appear to be similar, but their structures are not same. Why? The answer is, the structure of methyl isocyanate CH3NCO is as given below. We see that the steric number of nitrogen is 3, hence it is sp2 hybridized. So, C and C angle cannot be 180 degrees. Nitrogen atom has a lone pair on it. Hybridization of other atoms are also shown in the above structure. Now, let us draw the structure of SiH3NCO, which is known as silyl isocyanate. If we draw it at par with CH3NCO, then it must be as shown here. But lone pair on nitrogen won't allow it to be linear. The fact is that it is linear, and nitrogen atom doesn't possess lone pair. How this is possible? This is possible by donation of lone pair by nitrogen to silicon, which has all its 3d orbitals vacant. This type of donation, which is sometimes also known as back bonding, will form a pi bond of coordinate nature and is called d pi p pi bond. Thus, nitrogen is in sp hybridization state with a filled p orbital as shown below. Now look at the configuration of nitrogen, atomic number 7. It is 1s2, 2s1, p3. Basically it is 1s2, 2s2, p3. The ground state configuration of nitrogen is 1s2, 2s2, p3. But here, this configuration is given in some excited state, where a electron has been promoted from 2s subshell to 2p subshell. So the configuration which you see here is 1s2, 2s1, p4. Then S and p orbitals, which have been encircled. they undergo sp hybridization. One of the p orbitals is used for p-pi bond with carbon atom, and the last p orbital, which contains a lone pair, is used for p-pi bond with silicon. Therefore, the correct presentation of Si-S3-NCO will be as given below, and here you find that silicon atom is in sp3 hybridization state, the nitrogen is in sp state, and carbon is also in sp hybridization state. Hence, the part of the molecule from silicon to oxygen is linear. This type of d-pi-p-pi bonding is not possible in CH3NCO because carbon atom does not have any vacant orbital, and moreover, it cannot have d orbital in it. Next is question number 3. Which is a better electron pair donor or Lewis base, and why? CH3NH2 or CH3Cn? The answer is, let us compare their structures. In case of CH3NH2, you see that nitrogen atom carries a lone pair, and it is in the sp3 hybridization state. So the S character is 25%. But in case of CH3Cn, although nitrogen has a lone pair, but its hybridization is sp. So S character is 50%. Remember, more is the S character in the hybridization, more is the electronegativity of that atom, and less will be the tendency to donate the electrons. Therefore, CH3NH2 is a better donor. Question number 4. The 2 pi bonds in the molecule of CO2 are coplanar or not? Explain. The answer is no, they are not coplanar, but they are in perpendicular planes, because if x-axis is the molecular axis, then 1 pi bond is formed by p-pi, then 1 pi bond is formed by py overlap, and the other by p-z. Question number 5. In BF3 molecule, the BF bond length is found to be less than expected single bond length. Why? The answer is, since boron in BF3 is sp2 hybridized, hence it possesses a vacant p orbital, which can form back bonding p-pi with filled p orbital of fluorine. This is possible partly with each fluorine atom. It is called delocalized bonding. Hence, each BF bond develops a partial double bond character, which reduces the bond length as shown in the following figure. See, in the figure, the dotted lines represent p-pi delocalized bond. Then question number 6. Si-S3(3)N is planar, but CH3(3)N is not. Why? The answer of this question is that the structure of CH3 whole 3-ane, which is known as trimethylamine, is as given below, and we see that here nitrogen carries the lone pair. It is in the sp3 hybridization state, and therefore its shape is pyramidal.